Hi everyone, I'm Myles. I work as a data scientist for Jumping Rivers, and today I'll be talking about how we've used R to streamline our training pipeline. Now, Colin has already given you a quick introduction to Jumping Rivers and what we do. So we're a stats consultancy, we work on data science projects, also data infrastructure stuff, and we also offer training and upskilling across 40 different courses. So I'm going to be focusing more on the training side of things for this talk. So I am a trainer myself. I've taught about 200 hours worth of courses since I joined a couple of years ago. And I'm also one of the people that maintains the code infrastructure that sits behind our courses. So if something goes wrong, I'm one of the people that will be held accountable in that situation. So just to give a bit of background, we teach over 100 courses a year at Jumping Rivers, which is quite impressive for quite a small team, I'd say. Our courses cover topics like programming with Python and R. So we'll go from programming basics right up to more advanced topics like deep learning. And we also offer courses in a range of other languages and softwares like Stan, SQL, and Tableau. And up until 2020 or so, all of our courses were taught in person. So it's very much classroom style teaching. You'd have the tutor up at the front, live coding on the overhead monitor. The attendees would all be working on their own local installation of RStudio. The notes and the exercise questions would all be printed out physically. And it was very interactive, so it's a very nice format because for the attendees, if they have a question, they can just raise their hand, get instant response from the trainer. And as a trainer, it's just very nice being able to see the people that you're teaching. It's nice being able to see people nodding along, hopefully not falling asleep. So it's just a really nice format. So it's all working very well. But then March 2020 happened. And it doesn't really feel like 4 years ago at this point, but in case you've forgotten, this was when the first COVID-19 lockdown was announced in the UK. And so all of a sudden, we had to move all of our training across to online. So we initially tested online training internally using Zoom and just using the same format as we would use in person. And we just found it was very dull. It just wasn't quite working. We were sort of losing that interactive element that you get from teaching in person. You can't quite gauge the response of the attendees and their reactions. So we put a lot of work into making it more interactive. So basically having interactive quizzes on Google Docs that attendees can fill in, spinning up a bespoke training environment hosted on Posit Workbench that attendees can log into and access without having to install any of the prerequisites. But suddenly this meant that there's now a lot of work for the trainers because the trainers are now having to juggle lots of different tools and softwares. They have to make sure that their Wi-Fi connection is stable. They need to be able to see the Zoom chat for questions, make sure they can see the Zoom participants list so they keep track of absences. They need to have their live coding on one screen, perhaps a version of their live coding with all the code filled in on another screen, just as a sort of prompt. And suddenly there's just quite a lot to juggle. So to take as much work as possible out of the hands of the trainers, we try to automate as much of this training stack as we could. So we've done this using R packages that we've built internally in the company. And the basic idea is automate the setting up of the courses and the building of the courses so that on the day, the trainer can just focus on the most important thing, which is delivering the best possible course. So I'm going to give you an overview of our training stack as it currently stands. So first, this is Deborah. Deborah is our training administrator, and she's probably the first person that you'll speak to if you're ever signing up to a course at Jumping Rivers. So Deborah, she's a wonderful human being. She's got great people skills. She manages to bring in a lot of clients for us. But she's not a programmer. She can't run R code. She probably wouldn't know how to use a terminal. So we have to make sure that whatever training stack we come up with, it has to be a stack that she can interact with using an accessible interface, so without having to run any code. This is Oisin. Oisin is one of our R trainers, and I'm going to use him as my kind of model trainer for this talk. So when we are setting up a course at Jumping Rivers, this will always start with Deborah creating a task for that course in Asana. If you've not used Asana before, It's basically a scheduling tool. You can use it for setting tasks. You can assign these tasks to your colleagues, set due dates, and it's a really good way for timekeeping and that kind of thing. So this is how it will look when Deborah adds a course. So you'll have a title for the task, you'll have the start and end date, you'll have the title of the course. So this is Introduction to R. She'll assign it to the trainer, in this case Oshing. And although you can't see it here, there'll be lots of other fields. There'll be the type of course, whether it's a Python or an R course. There'll be details on, for example, what the Zoom link is going to be for the training. And basically, we have an internal package called JR Droplet, and this will parse all of these details from the Asana task, and it will use these details to spin up a bespoke training environment for that course using the materials that are required for that course. So the way this works, you run a function, you'll input the URL to the Asana task, and this will then spin up a virtual environment in DigitalOcean, and it will pull the materials for that course from the code repository for that course on GitLab. So on GitLab, we'll have the artifacts from the most recent build of the course. So here we've got a snippet of the PDF notes. Here we've got a little snippet of the exercises for that course, and I'm not expecting you to actually read any of this code. And basically it will take those artifacts, it will install all of the course prerequisites in a training environment, which is it's a Posit Workbench instance. It will set up a welcome page, which attendees can use to gain their login details. The attendees can then access Posit Workbench, which is a nice cloud environment for developing R or Python code or other languages for that matter. So in Posit Workbench, you can have a Jupyter Notebook session, say, if you're doing Python. You can have an RStudio session if you're doing R. And once the package has done this, so once our JR Droplet package has taken those course details from Asana, pulled the course materials from GitLab, uploaded these to a cloud training environment, it'll then send through a notification to Slack, which is what we use for our internal communications. It's very similar to Microsoft Teams, if you've used that. So here we've got a post on Slack. Oshing, the trainer, is tagged in this. He has some details about the course. So you can see the URL for the training environment that he's going to be using, the password, and now he knows everything he needs to know in order to get started. So he can now log into that environment, check everything's working, and then he's good to go for training the next day. Okay, so using this single R package in the middle, that sort of water drop symbol, JR Droplet, basically we've automated this full process, and we've managed to build this in such a way that Deborah, who doesn't have any R experience, she's able to add a course using this very accessible Asana interface, and then everything else is taken care of from there. So this is an R conference, so I'm going to be talking about how we've used our R packages in this pipeline. So I've already talked about JR Droplet. For the remainder of this talk, I'll be talking about how we've structured our GitLab and how we arrange the R packages that we use to build our course notes and that sort of thing. So in particular, we've gone for quite a standardized approach. So making sure that the code repositories for all of our courses have a consistent structure. Our courses can all be built using similar tools. And it basically means that if anything goes wrong, it should be relatively straightforward to debug and fix. So the way our GitLab is structured is we have a central repository. And in this repository, we have all of the R packages that are used to build our course notes, our course scripts, our slides. So essentially, these will take the kind of R Markdown content for that course, and it'll render these into PDF, HTML, that sort of thing. In this repository, we also have the make files. So in case you've not used a makefile before, because it is maybe a little bit old-fashioned, the idea is that a makefile will have a series of bash script commands. And basically, when you just type in the command make, this will run through all of these commands for you. You don't even have to know what's going on behind the scenes. So we use makefiles to build our course notes, to deploy our courses, and that sort of thing. We also have GitLab CI/CD. So, for example, we'll have certain rules. For example, what the GitLab runner should do when we make changes to a course repository. So that will always start by attempting to build the course materials. If the materials can be successfully built, perhaps some of the course details have changed. In that case, the Jumping Rivers website will need to be updated, so that will then send through a merge request to the website. So all of this can be automated and managed just using the DevOps tools found on GitLab. In the central repository, we'll also have any template files, which are essentially going to be repeated for each course. So every course will need to have a README file with the details about the course. Every course will need to have a config file with the current version number for the course and the current list of trainers. And all of this is checked and validated every time we build a course. And essentially the idea of all of this is to have a standardized course structure. So having all of the courses being built in the same way pretty much. It basically means it's relatively straightforward when you're adding a new course because you've already got the template there. And everything is just taken care of basically by our packages behind the scenes. So that's our central repository. So that's where all of this is defined. And then all of this is then sort of passed downstream to our course repositories. So in the case of R, we teach about 25 R courses. Each of those courses has its own repository. And the way these are structured is all of the materials will be written using R Markdown. R Markdown, it's very similar to Quarto, what Nicola was talking about in her talk. So you can use this for rendering documents with embedded code, and that code can actually be dynamically executed when you generate the documents. So you can have figures, tables, that sort of thing, all being generated from within the document itself. So we use R Markdown for our notes, which are compiled as PDF, our slides, which are rendered as HTML, our scripts and exercises, which in this case we take the initial R Markdown and we'll convert this into .R scripts with just the code and comments. And as well as our R courses, I have already mentioned we do also teach courses in Python and other languages. So what has to change for a Python course compared to an R course? Well, the main thing is that the code chunks in the R Markdown scripts, these will have to be written as Python code chunks rather than as R code chunks, or it'll have to be SQL or whatever language you're teaching the course in. But that's actually all that has to change. Aside from that, everything else can stay the same. So even though it's quite an R-centric approach for building courses, we're using R packages to do this, we can still keep the same structure as long as we're making sure our code chunks are in the correct language and the kernel that would be used to execute that embedded code is running under the correct programming software. Okay, so this is how it looks in terms of our GitLab. So what happens now if I try to make a change to that central repository? So perhaps I'm updating the format. So instead of using R Markdown, we're now using Quarto, say, for our slides. And perhaps I'm feeling a bit mischievous, and I'm introducing a change that may include a bug. Well, all of our changes at Jumping Rivers, anytime we try to update a repository, that always has to go through code review before it can be merged. So it's probably going to be Colin who is doing my code review in this case. Now, I hope that Colin is very careful with his code reviews. I would hope he's testing the changes meticulously on his machine. But just in case he's feeling a bit distracted someday or he's having an off day, he might merge this without spotting the bug. So what happens in that case? Well, we have an alert system in place. So the way this works is if you make any changes at all to that central repository, the CI for that repository gets triggered. So we check that we can still run the unit tests. We check that the course notes can be built for, say, just a template course. Even if that passes, we'll then trigger the CI for some of these downstream course repositories. So with these updates to the central packages, can we now build a couple of our Python courses, a couple of our R courses? And if any of those fail, the fails will be sent through to Slack automatically. So we've got a connection between GitLab and our work Slack. So any courses that are currently failing, these will all be sent through to Slack, and the trainer who manages that course will be notified. We also have all of our courses on a monthly schedule, so they're all tested monthly, and so we're basically doing a regular health check just to see what works, what's not working. Okay, so it's all very secure, and the idea is to test this whole pipeline rigorously so that on the day of training, the trainer can be sort of rest assured that, that everything should be working on the day. As well as these tasks that I've gone through, so setting up the whole training pipeline, you can also use R for the more mundane sorts of tasks. So at Jumping Rivers, we use it for a lot of the kind of administrative tasks around our training. I'll not spend long on this slide, but we've also built internal R packages that can be used for generating quotes for our courses. So we'll have all of the prices stored on a secure location on the cloud. And then all of this will be generated automatically to eliminate human error. Any post-training certification can also be generated automatically for that course with all of the relevant details for that course. And for the attendee feedback, at the end of the course, a trainer can just run a very simple command from their terminal, which will generate a type form, which can then be shared with the attendees after the course. So we automate as much as we can. We try to avoid having to perform sort of repetitive, tedious tasks every time we're training. So coming towards the end now, so I'm going to just ask whether this was all worth it in the end, because after all, there's only so much time that you can spend automating a task before you're actually spending more time than you're saving. In this case, because we're teaching these courses so regularly, over 100 times per year, I think it's definitely been worth it. And just to go through some of the benefits, one of these is having less duplication. So having this kind of centralized structure, it means that any functionality that's going to be there from one course to the next, that can all be stored in just the central repository. And in theory, it should be relatively easy to write new courses, because if everything follows this predictable structure, I can just run a single make command that will set up the kind of skeleton for the course for me. And then I just have to essentially fill in the R Markdown script with the notes and the exercises that are going to be specific to that course. In practice, it's not quite so straightforward, because what if I want to write a course in a new language that we've never used before, like SQL or something? Then I have to maybe get a bit hacky, think about some ways that we can render the exercises for that course from R Markdown, and then it suddenly isn't quite so straightforward. We also have our issues being flagged instantly, so if there's anything wrong at all, this has been picked up by the GitLab CI. The notification is going through to Slack. And the most important thing of all is that on the day, the trainer can focus on what matters, which is delivering the best possible training for the attendees. We're teaching over 100 courses per year, so clearly something is working if we're able to make that work with a relatively small team. And by having everything, all the sort of complicated stuff done by internal packages, it means we're able to work from quite an accessible interface. So someone like Deborah, who hasn't done R or worked on a terminal in the past, she can add a course relatively easily just using this nice Asana interface, which we then parse the course details from. There are a few drawbacks. So as I've already mentioned, it is quite an R-centric approach. And that's because originally Jumping Rivers was only really teaching R courses. It's only later that we started adding Python and SQL and Stan. So one of the changes that we may be making going forward might be, instead of using R Markdown for all of our slides, we might switch over to Quarto, because that is basically R Markdown, but the idea is to make it a bit more sort of multilingual. The course structure can also be quite restrictive. So you're tied to having the notes, the scripts, the slides all in a certain format. But what happens if I want to add a new element to a course? What happens if I want to have, say, Quarto slides with embedded Shiny apps or something like that? Then we're going to have to think a bit, how can we add this bespoke element but still make it work with our existing make routines? And then we've also got the slight issue of having everything so centralized. It means that one change to that central repo has the potential to break 40 code repositories pretty much overnight. So if I was to go ahead with making that change, that slides should now be QMD, so Quarto files, rather than R Markdown, that will break probably all 40 of our courses. There are some steps that we can take. So we can update the internal R packages so that these will automatically convert across the materials of the courses. So you can automatically convert the files from RMD to QMD. You can maybe go through these files. convert the code chunk options, for example, which may be using the R Markdown format, converting these over to the Quarto format. So we can still automate some of that, but ultimately some of that will come down to the trainers having to work through those courses and just fixing any issues that come up by hand. Now, this talk, I appreciate it's been mostly themed around education type stuff, but I would hope that you'll have some take-home lessons which are applicable to any coding project. So hopefully you've found something useful, even if you're just working on R coding, say. So some of the take-home lessons that I would say would be having a central location. So any code that is going to be duplicated from one repo to the next, rather than duplicating it and having multiple places where you have to debug that code, having that just in a single location where it's visible to your other repositories, I think is always a good idea. Packaging your source code. So when I say packaging, I'm not necessarily saying publishing your code to CRAN, but just publishing it to, say, Posit Package Manager or similar, just a package manager that can be shared internally across your team so that your colleagues can install your packages relatively easily. Making full use of the native CI/CD tools that's made available by GitLab and GitHub and similar. So I'm sure most of you are already using version control with Git, but you may not be making full use of the kind of DevOps tools that are also available by GitLab and GitHub. And it's just a really nice way to kind of automate the build of your software, the testing of your software, and the deployment. And you can also store artifacts on GitLab from the most recent build of your software, which is really helpful. Always remember to focus on what matters most. So in our case, that would be providing the best possible training for the attendee. So you could well try to automate everything, but then you're going to be very restricted with what you can offer on the day. So sometimes it may make sense to not quite automate everything. You still want to be able to insert bespoke elements here and there. So always just bear in mind who are you actually targeting from this, and making sure that it still solves that particular problem. And last but not least, think about your colleagues who are going to be using the softwares that you're building. It's very easy to get in the mindset that everyone has the same technical expertise as yourself. But just think about your colleagues, which of your colleagues are going to have to interact with the software. In our case, we've got, say, Deborah, our sort of admin staff interacting, and just making sure that everything is sort of as accessible as possible. It just helps to kind of nurture a sort of inclusive, open environment within the organization. So that's everything from this talk. So if you'd like to learn more, you can follow us on Twitter or X or whatever it's called these days. And you can view our webpage, jumpingrivers.com, where we've got all of our courses listed. And you can also access these slides at the link at the bottom. So thank you very much.
Thank you.